Okay, I'm just going to record an update on the particle renderer. So I have an LOD system set in, and also like this dynamic particle size that changes based on your distance. And then I'm also applying the normals to the data set so that it kind of looks like the form that we want it to. I also have it recorded in the VR headset that I can show as well. Before I get into the script and how everything's working, I'm just going to go through what the options are that I've outlined in the inspector. So we just assign the data asset that we created with the data loader, and then assign the Niagara system, which I just have right here. And then because sometimes the data set is like off center, so if I pause this really quick and I put this to 0, yeah, so the root is separate from where it is. So if you have to adjust the offset, I've put it in there. And that the major LOD distance is kind of the root of the system, and so this is where that root is going to be for the distance calculations on the bigger scale. And then I have this LOD intensity. So basically what this does is when I'm decoding the textures, basically every 6th point entry gets added to the static points. So that would be the points like when you're further away. So this is like basically 1/6. And then when you're closer, it spawns in the remaining points in between them. So it distributes it evenly, which is helpful if your data set is organized by position. Then it doesn't like just delete like the bottom third. It basically just evenly distributes where it's pulling those from. So hopefully to keep a good density ratio. So the point size difference, this is kind of a two subsystem. So the scale is really how it's going to be applied distance wise, like how it changes in distance. But if you just want like overall everything to be slightly bigger or smaller, I can bring this down, and then every point is marginally smaller. And then if you want kind of the scale difference, as in like be much bigger further away and much smaller closer up, you can raise this. Let's bring that back to 1. So yeah, but it gets pretty chunky pretty quickly. Set those back to defaults. And then the other thing that I was kind of running into with the data set is a lot of, I'm not going to pull up the data set again because it takes a while to load it, but the point values, it seems, I was looking at the raw data on it, and the point values kind of range from like 1 to 5, and for like world space positions, I wanted to multiply it so that I wouldn't have to do it in the transform up here. That's mostly because it interferes with like the local positions when you get into the Niagara system. So I wanted to leave this 1, 1, and then I'm scaling the actual point data as they get loaded into the textures instead. So now this editor utility widget creates, instead of creating the textures directly, it will create this point cloud data asset. Okay, so this is what the data asset looks like. And it basically gets an array of all the variables you need. It keeps a reference to the name, the texture size, and this is settable. And then the point cloud is dynamic based on how many points are in the data cloud. So you can upload a data set that is smaller than how much points would be available. Like let's say if I chose 512 texture size, but I still only had 65,000 points, it would still load this and then give the point cloud, the point count data accurately that I need for later use. Okay, so this is the main renderer script that is instantiating the textures from the data set. So these are just initializations. So where we really get going with stuff, this is a setter method that basically just gets the output, the override parameters for specifically those textures, and creates the data interface to send those textures into the particle system. So what I'm doing here is I'm loading the point cloud data asset from the path that we have. And then once that's loaded, I'm basically iterating between, I'm taking information from them and adding them locally. So I'm setting our local texture size and point cloud to like from the data cloud asset. And then our positions, colors, and normals array is the size of the textures that we need. And then like setting the region for those particles. So here I'm instantiating the point cloud system. So this is what we referenced. Like this is what you drop in the inspector. And I'm placing it basically as a child of the root component, so you can move it around the scene. And then we just have normal initialization stuff for this method. And then here's where we create the position texture. So we're creating the texture. So we create all three textures as these transients. And then after they're created, we set the Niagara variable. So we set the reference to it. And then after it's set, this is kind of a weird one, but you have to basically create the textures, set them to the Niagara, and then we can write in the information. If it's done the other way around, then it has issues. So I'm basically just iterating through and pulling in and writing the data to those data arrays, the local data arrays, in the UV cord. Like the reason I'm doing it kind of in this for loop structure is I'm doing it according to UV coordinates, so it's easy to decode later. And this is where I'm implementing the scale and offset. So it's being directly applied to the data before it goes into the textures. And then, so filling the XYZ variables, the RGB variables here, and then the NX, NY, and NZ, like the normal variables. And then if, like, let's say our texture size can support more points, it'll just fill in the rest with like blank values, which those won't be read by the Niagara system. Those will be cut out, but it makes it so you can apply, you don't have to have the exact amount of points that these textures can allocate for. So here is basically where I'm updating the position, color, and normal texture with the positions arrays that we have. And then as soon as that's done, I am unloading the data asset because to free up memory. And this all happens in the begin play. So this will be compiled like when the application starts, and then so this data set will be unloaded by the time like the user starts playing. And that's the core functionality of what this does. It's basically just setting all of the variables that we need. And like I said before, if we're updating this to like be an update script, what we could do is have an array of these data assets for like each update position, and then we would just move in. This stuff would stay all in begin play, but we'd move the arrays and the texture updates into an update method, so that it would update on the new information each time, and then it would update that texture. But because we're just updating the exact same texture, the reference to this texture or this link that we made to the Niagara system earlier on, it will continue to update in that. So this is going to be the kind of Niagara system overview. So in here I have a bunch of different modules that do different things. So I'm just going to kind of go over what each one does. So this is basically just a check to see what state of LOD it is in, and that's pretty simple as far as like it just takes the LOD distance from the engine owner, and then we import the LOD threshold from the user exposed variables here, and then that basically gets our current state for each emitter update, which I have setting to loop every half a second. And then we go to like the spawn count. So this is just kind of another like variable setting script. So based on the point cloud point count and then the LOD density, we're going to load either the static spawn count or the LOD spawn count. Well, I guess both of them. So this is where it basically will be, change that a little bit. Yeah, so we're just dividing the point count by the LOD density for the static spawn count, and then just taking the remainder of that calculation and filling the rest of for the LODs. And then static points, so this is going to be spawning all the points that we need for the static one. So I'm using this loop count variable from the emitter settings, and if it's on loop count 0, which basically means the first one, then it's going to spawn the, I'm just going to pass in the spawn count variable, which is set, so I have an input on that, and then that's set from the output of that spawn count one. And the rest of this is very similar to spawn burst instantaneous, which is just copied over from that module. But basically, I just linked into it based on it will automatically ignore it if there's 0 spawn count. So what I'm doing is I'm just immediately setting that spawn count to 0 if here. Here if we don't want to spawn that frame. So this will get bypassed on some subsequent passes. And then the spawn LOD points is kind of similar to that, but I am taking into account which state it is and if those points have been activated. So if the points have not been activated and the LOD state is positive, like meaning that they should be there, it will set the spawn count to that amount. And this kind of goes into the next, okay, so I guess I have one more thing to do on this part. So the LOD status, this is just to check afterwards to set the previous state. And then this is checking based on if these, basically this LOD points is activated by the output of the spawn of this frame in the spawn LOD points, like this one. So I'm inputting that there, and then that's just keeping a reference basically, like past this one. So this basically just spawns the count of the static points, and then if the LOD points should be spawned, this will spawn that amount of those. The other thing to consider with these ones is these also have a spawn group. So if it's the static points, my spawn group is 0, and if it's the LOD points, my spawn group is 1. And then, so for this is kind of where we start getting into the decoding. So on initialize, basically this is going to be iterate through every particle that gets generated. So we have each of those particles that gets spawned, and this is where each of those get initialized. So based on the spawn group, so if it's 0 or 1, this will be different. So if it's if it's spawn group 1, meaning that it's going to be the LOD, or I guess I'll start with the other one, the static variables. It's literally just going to take the execution index and multiply that by the LOD intensity. It'll set the point ID, which is a particle attribute that I created here, to that. So basically, if you had, let's say, 100 points, then this would count by 6. And then this is basically doing the opposite for the spawn group 1, which is the LOD ones, where this is just an algorithm, this equation that I made to basically just fill in between. So basically any integer, this will fill in the in-between integers. So if this is 0, 6, 12, then this would be, if this is counting by 3, so if we did 0, 3, 6, 9, then this would be 1, 2, 4, 5, 7, 8. And so on. So it'll keep doing that. And then so that's a specific attribute for the point ID. And we'll use that later for decoding the textures. The LOD point itself, this is another attribute that I've added. It's just a Boolean where if it's the from spawning group 1, meaning the LOD point, then we're just setting that to true. And we'll use that to be able to delete the points later. So in the initialized particle, this is just this is a default module, but yeah, this will just instantiate those. They have a lifetime of 1, but I've turned off the that doesn't matter too much because I'm not updating it by lifetime. I'm updating them manually, so the lifetime doesn't matter too much. So here's the apply textures. This is where like kind of the texture decoding comes in. So all of this is really just to take the UV map coordinates and assign them to the texture data that is available to that. So that is getting this. This is just a UV coordinate basically, and then we're inputting that towards the sample textures and taking in our color, position, and normal textures, and then we're just setting the color data, the position, and the normals from that. And because this is executing on point ID, the execution order doesn't matter because
each one of these point IDs is what really corresponds
to the data to the data in the textures. Okay, so then the last one, is the LOD point update, and I need to separate this into. I'll probably separate this into 2 different sections so it's more readable. But this is just doing another LOD check, and mostly for this is a per particle LOD check, and then if we are basically in the range that outside of the range that the LOD points should be spawned, it will, and the LOD point is an LOD point, then it will just set that all live to it will kill that particle there. And then the second part of this is the dynamic sprite size. So from this one, because this is updating, the kill logic is updating every frame because it has to with the particle update. But the emitter update that's spawning particles only happens, I have it set to 0.5 seconds, but I can even lower that to 1 for performance reasons. There might be a time delay between when it gets initialized and when it gets deleted. So instead of using just the distance check here for managing the sprite size, what I'm doing is I'm taking the total point count and versus the execution count, meaning all the active particles now. And then I'm using that instead for to determine if what size it should be. And so basically this check is just saying that if all points are not active, so if this is true, meaning the points have been killed, we're doing an input minimum of the LOD threshold, which means that's a distance that's set, and then the input max, I just have it set to 500 because that's basically when the particle should be the max size, and I think it's an arbitrary number, but it doesn't really matter. It could be 400 or it could be 1,000, depending on how far out you want it to be able to scale. And I guess in a bigger picture, I'm using these values to remap the range for that particle size, and then so if it's false, meaning that those particles are there, I'm remapping it with these values, which are calculated from the LOD threshold and the point size scale. Yeah, and so those are being. So the value of the distance is being remapped between these variables to give us the size, and then I'm just using that coordinate for both the X and Y on the sprite size. So I guess I'll give a bigger overview of the whole system of now that the details are kind of through. So my whole goal was trying to limit as much as possible what's updating every frame. I was trying to find an alternative to even having a particle update at all, but it turned out I just had to have one. Where I wanted something like the spawn, where it iterates through each particle, but only one time, and that really just wasn't possible for deleting those particles. And the reason I did it this way is because there is. Let's see, where is it? There are scaling abilities, so we can do this like enable distance culling, which is the normal scalability settings. But the real problem with this like these particle systems are optimized for like continuously spawning particles, and then if we were to cull particles based on distance, and then you come closer to those particles, if we're only instantiating or like spawning them one time, and they're supposed to exist without like for a long time until they're killed. If we kill those particles when we walk away, when we come back, they'll be gone, and you won't know which ID or which particle in particular was killed. So becomes hard to manage like coming in and out of the distance threshold range. Yeah, and the other ones are. I am using visibility culling, but I'm doing that with my render settings instead of through here. So I have this turned off because it didn't really help for what I needed. Once again, just trying to, like, I'm not spawning particles every frame for performance reasons, so that's why I'm doing it that way. Yeah, and then if we were to update this to like, there is an easy way to change this to an updating one. So if you had motion particles, but the particle amount is not changing, that's really where the difference is the particle amount changing is like this update and kill needs to be static. But if you just had a difference or like a change over time of the positions, then what we could do is just move this apply textures into a particle update, and then we just write new texture values each frame from like the script, and then that's how we could like change the position of those particles. Yeah, so that is kind of just a brief overview. I'm gonna give a more in detail. I'll probably give away like a video of constructing all of this from scratch, so that it's easily understandable. But that's kind of my overview for this system.